Thank you for joining the October 17th, 2019 VOLTA call. Just a reminder to everyone, these meetings are public and recorded, and we post them to our YouTube channel after the meeting concludes. Please be mindful of that during discussions and with any presentations that are shared today. With that, we'll take a quick look at our agenda. We've got two main topics today. First one is a continuation of the discussion that we've had over the past couple of weeks on device and port state transitions and actions. And so Ken has updated his document again, and we're going to continue review of that today and try and resolve some more of those open issues. And then we also have a continuation of discussion from last week, led to a discussion on transactions and a decision that we needed to have some more discussion time related to transaction boundaries and getting some definition around what it means for a transaction to be done in our context. With that, then also, if we do have any all discussed JIRA issues, with any remaining time, we'll take a look at those. So Ken has also prepared some material to guide us through the transactions discussion. So I'll be handing over presentation rights to him for the majority of today's call. Any questions before we start? Okay, Ken, I will give you presentation rights. You should have them in just a moment.
Okay. Just hold on. Okay, can you see my screen?
I can see the screen. Let's see. Yeah, I think we see what we need to. So I see the table. I don't see the sidebars, but I think that's fine.
Yes. I just wanted to make it bigger, so it's...
Exactly. Thank you for that.
Yeah. Oh, okay. So on Tuesday, we went for a big chunk of the document. And there was one item that I hadn't read and I didn't talk about it. And we browsed over it very quickly. It was for delete device. Currently, when we delete an OLT, for example, it still shows as, we still see it in ONOS. Do we want those devices just to disappear in ONOS? Or is it just a design thing to leave it there temporarily? Anybody knows about that?
I don't know if it was a design thing. I just don't know if we ever really thought that far into it.
You mean in ONOS?
Yeah, in ONOS.
Yeah, in ONOS.
Yeah,
right now, when we delete it from VOLTA, the entries still show up in ONOS. Is that current behavior?
Yeah,
that's the current behavior because it thinks that the switch is temporarily unavailable and it could appear anytime. So that's why it marks the availability as false. Because ONOS doesn't know you deleted it. It probably thinks that it has just become unavailable temporarily.
Okay, so in that case, do we just then expect administrative API that deleted the device out of VOLTA to also administratively delete the device from ONOS?
Yes, so we have to administratively delete from ONOS as well.
Yeah, but how does that work? I mean, we discover the presence of an ONU, but the ONU may match something on the whitelist, right? So it's still a valid ONU from the system database perspective, but it's just not present.
We were discussing about the OLT.
Oh, sorry, the OLT. My mistake. Sorry, I just joined. I guess I should listen more. Sorry, go ahead.
Yeah, I mean, I guess this is maybe just a kind of a northbound, NIM layer type of activity to reach into ONOS and VOLTA and clean up after itself if it needs to delete the OLT. I mean, I'm okay with that.
Okay, in that case, we'll just, because it's not really in the VOLTA realm to do anything about it, so we'll just leave it to ONOS to figure it out. what to do.
Yeah, I think so.
Okay, so let me go to the last part that we have not covered last week. Well, on Tuesday, we went briefly over port status update, where we mentioned that the core will not replace flows, but for trap flows, currently we send decomposed flows to only the parent. So this will be changed to, for certain conditions, to send to both the parent and the child. Are we all okay with that?
Yeah, I'm okay.
Yeah, patches are forthcoming maybe today.
Oh, perfect.
Well, I hope so.
Okay, and then there was an issue that I believe it was Amit that raised, that it's if we need to have an API between the adapter and the core to mark a device as unavailable. For example, during a reboot phase, for example, that device we can't really do anything with it. Is there a need to have such APIs? And basically what it will do, it will just, any request on that device during that time will just be rejected because that device is just not available. Do we need that? From an adapter perspective, especially.
Unclear what the API does. It just tells the adapter not to do anything.
It just marks the device as it's in a state where we can't do anything with it. We have to wait until it's become really available.
And who would call this API? I'm not clear.
Yeah, the name of the API would pretty much it would be like device unavailable. Like I just put that in there. It could be any name. It's just like yeah, go ahead.
The adapter would call that API into the core saying that the device is unavailable. Is that the scenario?
Yes. Yeah, I believe this is what Amit meant when he raised that point. It's really for situations where the adapters knows those devices cannot do anything at that time, and there's no point of sending more requests.
But when a device reboots, doesn't it get the status go to unavailable during that time anyway, because we can't reach it via the network, and so the core gets that update from the status from the adapter?
I think so.
Yeah. So GRPC connection will go
down. Yeah, so why would we need an API? It's just the core will get the unavailable status anyway, and then it can do whatever it wants to do when the status is unavailable.
Yeah.
Yeah, I think opera status down, as reflected either by, asking the agent or the agent telling you from an indication that some opera status is down, or if you can't reach the agent and opera status becomes unknown. I think both of those are covered by that.
I would think so. Since well, Amit is not online, so it's so I talked to him offline to figure out like if there was a different scenario that he was thinking of. And the next one is I think we no longer need that. Is refresh flows. Do we need an API from the adapter to request a call to refresh its flows?
I don't think so. The only scenario I can think of is like when the adapter goes down, like crashes or restarts and comes back up again. As long as the reconciliation process covers at least reinforming the adapter of any flows that it used to have, I think we're covered there.
Yeah, I guess the adapter doesn't really know, right? I mean,
yeah, if the adapter itself goes away, then there's part of reconcile should be some reinforming of the flows, or among other things, and that I think that's the only scenario where all of them need to be, the least reintroduced.
Yeah, in theory, if the adapter goes away, then I guess all the ONU devices go away, and then all the flows would be withdrawn by ONOS. Unless ONOS isn't there, I guess, which is another scenario. But,
yeah, if the adapter goes away, I think this is part of the state sequence Ken described. I think everything would go, if it's the OLT adapter, everything, the OLT and the ONUs would go unknown. And how that's reflected in ONOS, I think, is basically as if it's all down. I could be wrong.
Yeah, so we still have to figure out how the state transition that we need to do that, because we don't do anything on unknown at this time. It's something that we have to figure out how to present that to ONOS. So bottom line, the last two rows in that table are not required. Are we all okay with that?
I'm okay with it.
Okay, cool. The last point there, and I believe that goes a little bit with transaction handling, but maybe we can address this here as well, is if the core pushes flows to an adapter sends that to the device, if for some reason we're either doing an add or a delete of a flow, and that operation fails, what should happen? Should the core keep retrying, or we just send a failure back to ONOS?
I know at least for the ONU, it will keep trying. So whether it sends a failure back and keeps trying, or sends back a success indicating that the adapter has it and I'm going to keep trying forever, I guess is really the question.
yeah,
So
I guess if
normally
okay. Go ahead.
I was saying in the normal Ethernet switch state, if you push a flow and it fails, next time you query the flow, ONOS sees the flow is not there, and ONOS repushes it. Why? And we're talking about doing that for other situations. Why not continue to do that rather than have the adapter just push it, let it fail out? When ONOS does its reconcile, it'll see that the flow is still in pending add, and we'll push it again.
What triggers the reconcile there? Is that
Well, again,
a periodic audit?
Yeah, ONOS does a periodic audit.
Okay.
Yeah, I guess some of it is flow driven and not. I guess it depends on what you're doing. If it's for at least for the ONU, the pushing of VLAN flows is a pretty distinct path from ONOS all the way down to the ONU. But for some of the tech profile or OMCI activities, there really isn't as clear a path. So today, right now, the way it's built is, if for whatever it's trying to do via OMCI fails, it gets back a rejection. It just keeps trying.
Yeah.
For VLAN flows, yeah, I think we could, just outright fail and then bubble that back up. But for some of the other ones, like it's more like a decomposed.
Yeah, I would agree. If there's no path to ONOS, yeah, ONOS won't get indication. It's the difference, and it won't be able to reconcile and repush. For those things, I agree. We have to have another mechanism. But for anything that actually does bubble up to ONOS, I think let ONOS deal with it.
Yeah, the difficulty of having the adapter retry forever is like, how does the core will know that actually the transaction has failed? Because if it's retry forever, it hasn't failed.
Okay, but presumably the something's going to go down. I mean, if I keep sending something and I don't get any acknowledgement, there's going to be now the ONU, I can't communicate it with it, so it's failed or it's gone away, or it's in that case it'd be in some weird state because I haven't been told it's gone away, but my OMCI doesn't work. So something will take the OMCI down. There's going to be some. Yeah.
That would be the generic case, right? I'm just wondering if there's any scenarios where the ONU is retrying forever, we don't get any notification, and the flows are in the core. and the core doesn't know that their ONU is still trying.
I mean, I could see, just trying, the one time and then bubbling up the rejection, and then ultimately ONOS, if it does what it should do, should keep trying. Having all that driven from one place would simplify things, I think. I guess it gets tricky with decomposed flows. So let's say one flow turns into, 2 or 3, and one of those fails. Do we consider the whole of the logical flow a failure? I guess so.
Yeah.
I think we'll have to. Like currently, we don't have a mechanism to send a failure back, but we'll need to figure it out to send that, because coming from ONOS, it's a transaction for that request, and that OF agent gets that, but that doesn't get propagated to the core. So we need to make sure that gets propagated so that the event that goes back up has a transaction ID.
I think the cookie is preserved all the way through as well. Depending on how the flow and the decomposer works, I think that cookie from ONOS all the way down is copied between all the children flows.
Yeah, correct. The cookie are there, but I don't know if from an ONOS perspective, we can send an event based on the cookie itself, or it has to be a transaction, part of the transaction ID.
Excellent. All right, so I guess some exploration there would be needed to really do this.
Yeah, I think that's a good lead into the transaction lifecycle. If we don't have the comments on the device states, does anyone have any other comments on the device states document?
Yeah, I think this is enough to work from for now, at least to redo the states as we described 3 weeks ago, and kind of go with that, and then we can leave the flows to maybe a separate after we sort out transactions.
Yeah. Okay, so I'm going to switch to transaction lifecycle, which is another tab. Okay, so let me see. Can you all see my screen?
Yeah.
Yep.
Yes.
Okay, so this is how a request gets processed today. Like in the current core, and the same model follows in a way in the adapter. And we had the discussion I guess over emails and over VOLTHA Discuss about async requests and about when the transaction ends and failure mechanism. It was all all over the place. So I'm trying to put things in the document so that we can track it. So currently in VOLTHA, here I have a sequence diagram. I remove a lot of there's a lot of processing that happen between calls and everything. I'm just removing all those. I'm just putting just show the basic. Basically, whenever we get a request that come down from eventually come back down to the API server, which gets sent to 2 calls. But in this case, I'm just showing 1 call. What typically we'll do is we'll make some changes in the model, then we'll send that request to Kafka. The adapter will receive that request and will send back an ACT that it has received that request. And then in the background, the adapter will go and process that request. Once the core gets an ACT, it sends back an ACT to the API server and eventually to any part of the system that originated that request. And if there's a timeout, basically what it means, we don't get an ACK from Kafka, and it will send that back up. This is how it works today, in a sense of we don't really know a transaction is completed fully or not. All we know is, from a core perspective, it has sent the request to an adapter says, I got it, and then it says, okay, I done my job. This is how it works today.
Is each GRPC call being handled in a separate Go process, so that while it's waiting for the ACK of acceptance back from the adapter, other GRPC calls can be handled, or is that blocking all other incoming GRPC handles from, or requests from being handled?
Actually, it's not. It's basically like there's different levels here. Like GRPC itself has different threads, routines to handle each of those requests. So they already in GRPC they are separate, and in the core itself, there's different routines handling them. So you can have thousands of requests coming in, and thousands of requests waiting for a response. So they're all being done in parallel. Does that
right.
answer
Yeah, that answers. Just want to make sure the waiting for the ACK wasn't stopping further processing.
Well. So I guess one question around that is, can I block on a device, and when I say device, I'm thinking ONU, and wait for a response. So let's say I'm changing the state of the ONU. So if I want to do, say, an admin up, can I block on that device and wait until the admin up has actually been implemented, and then send the response back up saying, yeah, it's successful? And is that desirable, I guess?
Exactly. Like if we look at in the sequence diagram that we have, the moment we send a request to Kafka, eventually to the adapter, during the time that we receive that request for, let's say, for a specific device, there's a lock on that device. Means that there's nothing else that can happen on that device until we get an ACK back, and then we release it today. That's how it works. And there are good things about it, and then there are also like bad things, in the sense that we're having a lock on the device maybe for a long time, because if the adapter takes forever to send an ACK back, then that we can't do anything else on that device until that lock is released.
And also
a good thing.
Yeah. So I mean, the pros and cons. So I mean, you don't want to get into a deadly embrace situation where, the ONOS is sending out, let's say, an admin down for a device, and then the OLT adapter is sending up the device has gone away, right? So what would happen in the core if that happened? Let's say that the admin down occurred first from ONOS, but now I'm sending up the fact that the device has now gone away from the adapter. So, because now the adapters say I've locked my device, and so is the core, right? So now they've both locked it, but they're both waiting for responses for different transactions.
It's like the way it's handled in this case. We expect the adapter to send an ACK right away, like the moment it receives a request. When it sends an ACK, we release that lock today, because we don't know if the transaction is completed or not. We don't wait for it. So that lock gets released. And in the scenario where you're saying you get something from ONOS first, and then you get something from southbound coming into the core, it really depends on which request comes in first.
Some of the original question was, what is the value of waiting for that acknowledgement back from the adapter versus having the core basically say, hey, look, I'm using Kafka in a full deployment. Kafka has guaranteed messaging. I'm going to fire and forget versus fire and wait for an ACK. And essentially guaranteed messaging in Kafka underneath does the ACK for you, essentially, as I understand it. So, what is the value of waiting as opposed to say, core fires off and releases the lock right there? If the core code cares to understand when it has been accepted for processing, if you will, by an adapter, or when an adapter fails or when an adapter succeeds on that specific option. Those could be additional events that a process in the adapter could choose to wait for and monitor and do something of it. But this way, we don't have that kind of act for someone's accepted the processing. All we've done is fired it off and let it happen.
Yeah, so I guess there are certain events that we do want to wait, though. I guess, I mean, like a discovery, for instance, coming up from the adapter. I mean, it seems like you need to go create the device. There's a bunch of processing that needs to happen for that discovery. I guess, do you want to block anything else out?
Or do you fire the discover? Right? Do you discover the fire the discover event, and then wait for additional events to come back from the adapter that actually instantiate or invoke the creation of it? Right? Is there a reason to wait, or is it, hey, just I fired off the discovery event. When I get the results of that discovery event asynchronously, that's when I'll create the device.
Yeah, it seems like we need an arrow from the adapter back in the other direction, on its own to indicate a change, so northbound can then act on it. It's like that process request loop happens kind of off in its own world, and we don't really know whether it actually worked or not. So everything else is just going to keep throwing more stuff at it. You really need to have an arrow headed back in the other direction asynchronously.
Like the difficulty with the act per se, it's not something that it's really required. It was just a choice that was made at one point in time to say, okay, we'll say transactions is complete once we get an act from an adapter. So that can be changed. That's not an issue. To Matt's comments about this process request thing, where things get complicated, it's when you get a request coming from the core to the adapter, for example, an enable of a device. That process request implies there's a lot of requests from the adapter into the core to change the device status, change model, change a lot of things. So if somehow down the road that enable request fails, we already have a system where there's a lot of changes that has been done to it.
So maybe we need to look at the southbound ladder or sequence diagram, because it looks like the loop of process requests would be adapter originated requests.
Yeah. I have a slight diagram here. It doesn't show all the details here, but this is also show like today what we typically do. Whenever there's an adapter that sends a request to the core, it goes to the Kafka, it sends to the core, and there are two different set of requests that comes into the core. There are the sync requests, like for example, if the adapter want to get a device or get any information. So this is, I call it a sync in the sense of it still go over Kafka in an async manner, but except that the adapter will wait for that response. So the core just send it right away. Or there's an async request where the core will send an act and process the request in the background. And typically would be things like update some data in the core. So this is what exists today. And I'm going to move a little bit to, we're talking about, here I'm putting some changes, but also there's a lot of questions. For example, when we are talking about process all requests asynchronously, does it mean that we will need to wait until the final completion to send a status? Because we have different components that are involved in processing a request. Or are we going to send intermediate status for a request? Do we need that?
what would be the intermediate messages? I mean, I can see messages, you pass an async request onto Kafka. I can see a message that says, okay, I'm starting processing. I can see a message then for error and completion. What other intermediate messages are you thinking about?
Like, for example, right, like in the example that you gave, from the core perspective, it got a request and then does some processing and send it to the adapter. Do we expect, for example, the core says, okay, I finished stage 1 of it, and then the adapter which says, oh, I got this response, this request, I'm starting to process it. In that sense, do we expect those kind of behaviors? And typically, maybe those will be only on Kafka.
Yeah, I would expect that a message of processing beginning, if that's what you mean, I guess. I'm not sure I understood, but other than process beginning, I'm not sure there's any other intermediate messages, the, hey, I'm still working on a message type of thing.
Yeah, just the ACK says, okay, that message was delivered, right? I mean, it may not have started processing it yet, but it was delivered.
No, I was separating that, right? So
okay,
Kafka deals with the ACKs for guaranteed messaging, right? So the ACK, when the adapter gets it and ACKs back, that's actually when the adapter starts processing that message. Not just it's an acknowledgement of acceptance at the adapter, I guess. But at that same point, I think it's when it starts processing as well. It's not like the adapter gets it and queues it up and processes later.
Right. But then, is that useful? I guess. I mean, the fact that it's finished processing, so it's like an application level acknowledgement that I've done what you asked. Is that more useful in that case? I mean, rather than an intermediate thing saying, hey, I started.
I agree that the I'm completed or I've erred the most important message. Absolutely agree with that. But I think it's a very lightweight and very little effort to say, hey, I've begun processing. In terms of if we go to eventually place, say, hey, what's the status of my system? It's interesting to see what messages or what things have been accepted and started processing, what are finished, right? You kind of get this jobs capability out of it. And so I think for a single message to say, yeah, I got it, I'm ready to process it, that's lightweight, cheap enough that it could be beneficial down the line.
It could be a log message too. It could be as opposed to an application level thing.
Yeah, it could be, but I guess I don't see the downside of putting it as a Kafka message back up.
Well, it depends on the number of transactions and number of messages, right? And if this could be enormous.
Yeah, I guess, but
so I guess from the perspective of, say, a single OLT, right? It has, let's say, as in AT&T's case, it has up to 64 ONTs, right? So in the context of that single OLT, there can be transactions in flight around 64 ONUs, right? So it doesn't. I mean, that doesn't seem like it's huge in the context of a single OLT.
Oh, right.
But I think
is each one of those a different message from the core on Kafka?
Well, if I'm saying like each ONU is a device, right? So let's say we process things on a per device basis. So there could be up to 64 single events that come up from ONTs in the context of a single OLT, right, to the core.
Okay.
So then every one of those requests, I guess, let's say worst case would get an ACK, and then it would get that it was delivered, and then it would get another response saying I've begun processing.
Again, the ACK and I've begun processing are the same thing in my mind, right? We're not sending, because when the adapter or the client or the receiving side, when the receiving side doesn't ACK, that's when it's beginning processing on it, right?
No.
No?
Well, it depends. I mean, if each device has a lock, say, let's say I want to lock this device from doing anything else until I've completed processing something, then any subsequent message would have to be queued somewhere. So it was delivered to the right process, but it may not start processing it. It may be in a queue somewhere, right?
Oh, right, but we don't queue today, my understanding, right? So we don't do that. We get a message, we process. We get a message, we process.
Yeah, today we don't do that. It's something that we need.
So now, is that an issue? Because now, for a single device, I could be concurrently processing lots of different events, right? Some of them are probably not as important as others, right? So, for instance, if I've discovered an ONU for the first time, that's pretty important from the rest of the system perspective. That it gets up to ONOS and gets authenticated, etc. Right? It gets created. But just like an alarm saying, "Hey, I'm here," or my port changed state, or some other event, like I've crossed a threshold or a PM threshold or something. That's not quite as important as the fact that the ONU just arrived, right?
Right.
So, I mean, potentially I could get those out of order, right? I'm guessing, right? I mean, if I go off and process every single message, some may take longer to process than others. So I'm kind of out of sequencing this, what's happening on the system. I would assume, right?
I would agree that we need a queuing mechanism, that we can do priority queuing down as we process requests, both in terms of priority as well as in terms of call it target sharding, if you will. I agree that's there. We need that. We don't got it. We don't have it today. So then the question becomes, great. Is there a message that says, from when the core sends a Kafka message, does the adapter send back the ACK, I got it, which that basically means I've queued it, but it also means it's in memory, which means if the adapter goes away, that message goes away. Does it, or unless we want to do persistence as well, different issue. And second message, does it send a second message when it says, I'm now starting the processing of this message, processing behind this message. That's not going to be for every OMCI call. It isn't going to be a Kafka message from core to the adapter. So, if there's 64 ONUs, maybe there's 64 Kafka messages down. And yes, if there's a 1,000 ONU or 1,000 ONUs over multiple devices, then, or 1,000 OLTs, 64 ONUs on each OLT, yeah, we're talking 64,000 messages. I get that. I guess the question I'm still struggling with, if that becomes our performance problem, one, we got other problems.
Well, actually, I guess the number is a little different from that, because let's say there's 16 ports on an OLT, or 64 ONUs per port. So it's going to be 1,024 ONUs per OLT, I guess. So if I have 16 ONTs, so that's 16,000 ONTs in a SIBA pod. So so that's quite a lot.
And remember, for every single request, there can be multiple subsequent requests. That happens, right?
Yeah. And
even if we say we're not going to send a Kafka message, we're going to log it. It's processing time in the log. Are we trying to solve a problem that we don't even know we have yet? Is it okay? I mean,
look, we're anticipating problems, I guess.
Yeah.
And maybe we do have a problem. I mean, just from the trace that the guys from Tug Telecom were talking about. I guess some ONUs ended up in weird states. I don't know if that's because of this asynchronous processing of multiple events for the same device. I don't know.
I guess my opinion would be, and if people don't agree, if the majority don't agree, that's fine if we don't do it. My opinion would be, put the events in right now, and if they become the performance problem, take them out. If no one depends on them, take them out. I mean, the other approach is saying, put them in when we need them, or if we see we need them, and that's a valid argument. I just find it harder sometimes to insert these type of things later, than initially. I don't want to be religious about this. I don't care in the long run which way we do it. If it's easier to say, let's not do the ACK and the begin processing message right now, if that closes the conversation, because I'm the only one arguing on the other side, I'm good with that.
But I guess I would argue that maybe you could log that. I mean, as opposed to generating a message. I mean,
yeah.
Okay, we can start there. I'm fine with that.
Okay, let's move on.
This to me is such a minor point. I don't want to spend much time on it, I guess.
Yeah, let's move on. Let's move on to the other point. When we are talking about getting a complete response for something is when something is completed, you should be mindful that in some cases it's not possible to send back a complete response. For example, if we take the case of a CLI, doing a disable of a device, the device send that request and the CLI is not there waiting for a response. It will just do an query to get a response back. So there would be a situation where sending back a response, it's going nowhere. We are okay with that, right?
Yeah, I mean, sometimes when you complete a processing, it will no one's listening to the answer. That's true. I don't know if we want to go that far and say, hey, when I send this message, I'm going to indicate whether I care you send a response or not.
Some of it may be implied by what the action adapter takes. So sending a disable, if for whatever reason it hasn't made it yet, and the adapter hasn't done anything yet, then you won't see opera status, change, right? The disable isn't finished yet. Whereas when you actually send the disable, wait some amount of time, and then opera status is updated, then you know it actually happened.
Yeah.
The question is, when does the core mark it as disabled? As soon as it sends the message, or when it gets the indication back that's been processed?
The cost market disabled. Today, it's market disabled when you get the request to disable something. You disable it and then send the request to the adapter.
Yeah, admin disable. So let's say we say disable it. I think the core would set the admin state to disabled straight away, but then the adapter, per its getting that message, would then turn around sometime later and set opera status to down or whatever we decided on.
Yeah, correct.
All right. I mean, the question then becomes, do we allow this to be always send a message, or is there some indication when I send a message I don't care about the response? I worry a little bit about implying, because, well, it's non-deterministic when you look at things, right? One person may understand the implication, the other one might not.
Yeah, and what if I say admin down, then admin up like 2 seconds later? So basically from the core's perspective, it's up. What is it from the adapter's perspective? We don't know.
Well, I'm hoping the adapter gets those messages in order and turns it down and then immediately turns it up.
So in the case of, because we're talking a transaction, not just between the core and the adapter, it could be like from northbound to the core as well. For example, for requests that, like in the scenario where we are talking about the disable of the device, we need to respond to that request. Do we wait until that request is completed, or we send a first act saying, okay, that's we got the response, we're going to process it, and then later on, if that GRPC connection of northbound is still open, we'll send a completion, or if it's not, then it would be the northbound that will have to go and query the state of that device.
So a GRPC call comes in to be disabled. The question is, do we wait on that GRPC call until we get an ACK back from the adapter that it's actually been disabled, or do we return that GRPC call immediately once we set the admin state to disable, but before it's actually been processed? Is that the question? Did I understand that?
Yeah,
right?
that's the question, yeah.
if admin state is only a database state in the core, then I think as soon as we set that in the core, it's been set to disabled.
Yeah, I think the follow along upper status down as sourced by the adapter would then flow northbound in its own time.
Okay, so we are okay with that. That's good.
Yeah, the only problem I see with that, and I don't know if it's a problem from an operational standpoint or not, is once I do an admin down, I still may see packets flowing until everything's processed. And I don't know if that's a problem from an operations perspective or not.
Well, I mean, I think there's always some level of delay, right? Part of the disaggregation price is going to be that delay introduced as we bust things apart. So, yeah, I mean, if everything was closer to the hardware, then that tiny amount of delay would be really tiny.
Yeah, you could have a bunch of packets waiting to be sent upward, and during the same time there's an admin down, right? So those packets will still be sent.
Yeah, I mean, in the legacy world, I mean, the requirement was to wait until it's actually implemented in the hardware, but before acting back to the the management system. But in the disaggregated world, that's probably not viable.
Yeah, so we kind of faced this situation with XOS a bit in that we had the same API where we tend to, we have a request and it said something in a database, but that doesn't necessarily mean it's been acted on. And our assumption was always if someone wanted synchronous behavior on top of that, that would require them to implement some layer that takes our asynchronous API and implements synchronous behavior on it. Maybe the same thing applies here. If someone really wants to send an admin down and know that that admin down was acted on, then they need to write something that sets the admin down and then polls until it, or waits for the event to come back to see the operational status changed. And that's just a layer above VOLTHA if they want that behavior.
I prefer that behavior. This put less restrictions on VOLTHA itself. Okay, the next one, which is a little bit more fun, which is request ordering. I think Sean talked about that a little bit. It's do we keep a lock on a device until the request is completed? And here I give a scenario. Suppose we have a logical device that represents an OLT and two ONUs, and then ONO send us two flows, F1 and F2. And F1 is meant for OLT1 and ONU1, and F2 is meant for OLT1 and ONU2. Do we send, does the core lock the device for like OLT1 and OLT and ONU1, send those flows, wait for a response, a completion response, before sending the other flows?
Won't Kafka give those messages to the adapter in the order in which they're received?
Yeah. Kafka will.
So if the core sends them, essentially just floods them out, those should still be processed in the order in which they're received, yes?
Yeah, they would be processed in the order they are received. But if for somehow, let's say one of the first flow that we send down fails on the OLT, then the second one, do we need to get the transaction keep going, or should we fail everything else? Like,
maybe I missed that bit, are the flows considered one transaction or are the flows independent?
In my example, they are independent, so it doesn't really matter. But I'm just wondering, are there scenarios where they're actually dependent. For example, when we do a poll, it's not only one flow; it's a couple of flows.
That's okay, I think. I think if a given flow fails, that flow fails. The other ones succeed. That's great. When we bubble things back up, if there's a difference, I would think Onos would see that difference and then repush the flow. Yes.
Right, but does the transaction from external management system, is that successful if it only partially succeeds? It may succeed later on, but from a legacy perspective, the transaction either succeeds in whole or it fails in whole, right?
Right, and I'm using just this example. Ethernet switch today. I push a flow objective to Onos from a northbound system. I get okay. I get okay back, which means Onos is processing that flow. It does not mean it gets to the device. Right? So I guess I'm just from that perspective.
Yeah, I think it's probably better to talk about specific use cases. It's hard to kind of get your head around this abstract use cases, right? I mean, if you have a list of just a few use cases you could just talk through, that might be better.
Okay, so in this case, assume that there are different flows, right? F1 and F2, they are not part of the transaction. So do we expect the core to lock the devices for that flow, for the first flow, until we receive a completion, or until it sends it on Kafka?
I think until we send it on Kafka. Once we put the message out there, other messages can then be processed.
Right, I think so. I think if there's some other failure, again, in the adapter, then it's up to it to asynchronously report back up, kind of like we talked about earlier. Processing F2 failed for whatever reason, or F1 failed, then it would report that back up in its time.
Yeah, I think that's one of the kind of the mindset changes we need to make. And yeah, it's going to have some mindset changes all the way up to operations. Perhaps is, hey, look, you're essentially making a request that at some point may succeed or fail. It's no longer this, I do A and I wait until A is complete. At least from the Volta perspective.
Yeah. I think that what that means also is adapters have to stand on their own in terms of, not having too many interdependencies and reporting, report that back on its own.
Yeah. If someone needs a synchronous operation or synchronous semantics outside of Volta, then we're back where Scott was talking about. It can be done. The mechanisms are there. But Volta is an asynchronous system. I don't think we want to try to make it a synchronous system.
Okay, so what it means is the lock on a device within the core is from the moment we get the transaction, a request on that device, until the moment that it gets sent on Kafka.
I think that's what we're saying, yes.
I think
that's not much of a lock, though, right? I get requests and I send something off to Kafka. It's not. That's not much of a lock. I think, right? Unless we're saying the lock exists just within the core domain. So whatever the core needs to do, then it's locked while the core completes that.
Yeah, it's only within the core domain. I'm not talking about lock outside of it. It's just within the core.
Yeah, this avoids, like you said, some of the deadly embrace stuff where if the core is responsible itself for its own locking and it's not dependent on some outside process to fail or not fail, it keeps it from getting in a bad state. It may move the problem elsewhere, right? So now some other system has to sort out if failures happen asynchronously, what does that mean and how to react? but it keeps Volta at least, more asynchronous and protecting itself a little bit better, the core. But the longer those locks stay locked, the more likely everything has to slow down.
Mm-hmm. Agreed.
So in this particular case, if the core gets the act that the flow is delivered on the Kafka, and later the flow installation fails, so how does it get reported back to ONOS? And how? Yeah.
Okay, maybe we'll look at maybe we'll look at the next point, which is about request failures.
Okay.
So it really depends on what we want to do on request failure. Like, do we want to do a retry? Do we want to just propagate the failure back? Do we need to roll back any of those requests? It's
well, I mean, unless it fails within the core, there's never going to be a failure response, right? I mean, it's always going to be some kind of event, some asynchronous event saying this failed.
Yeah, if it's failed within the core, yes.
Yeah, so if it fails while the lock's there, for instance, then it can respond back and say, hey, etcd doesn't exist or something, or some failure of the request from the core itself. But once the core has sent that on to an adapter, then the failure mechanism is going to be some asynchronous event saying, hey, this failed or that failed, right? And then it's up to the system to recover from that.
Yes, so we're trying to determine like what that recovery process is going to be. For example, like if we take this example about flows, right? Where we have a flow, we decompose the flows to an OLT1 and ONU1, we send them to the adapters. The OLT adapter says, oh yeah, I got it, it was done successfully, but the ONU adapter responds with failure. So it's for the same flow. So what do? Do we send the flows to ONU adapter? And do we retries? Or we send a failure back to ONOS, and that means both the flows on the OLT and ONU needs to be removed. Is that what you do? What we do?
I think the latter. I think that's what we talked through, where basically if the ONU in its own asynchronous time says, I couldn't do what I needed to, sends a new request to the core saying, I had a failure. Then the core, then through its decomposition knowledge, then reports back up to ONOS saying that one flow failed, even though it actually succeeded on the OLT. And ONOS then at that point then repush everything, right? So the OLT will just have to suffer through getting that flow again and hopefully succeeding again. And then the next time the ONU gets the flow, maybe it will succeed this time.
Okay. Does that
mean
the
report back to ONOS isn't, hey ONOS, there's an error, because what's going to happen is ONOS is going to query again what flows are there, right? So it's not like the error is propagating all the way back to ONOS the minute the error propagates. The adapter might throw an error, the core might look at the error, I don't know, and say, okay, that means this flow's not there. But at some later point in time, ONOS is going to say, hey, what are your flows? And what's going to be reported back from Volta is that flow's not there.
That logical flow.
Yeah, that logical flow.
Yeah. Which means like that on the failure from an ONU or an OLT, that flow itself get deleted from the logical device and also from the devices. Even if the devices in this scenario, the OLT says I got it, so it will need to be deleted from that OLT.
I mean, we can argue that we can keep those partial logical flow out there and report that none of it's up to the propagated up to ONOS, and therefore when we get the flow push again, we push down. A lot of people say, I already got it, I'm done, versus the one guy will retry. I could see us doing that either way.
Yeah, or maybe if the ONU fails, the ONU becomes degraded, like another substate of the operational state. So it may be I'm trying to add a VoIP service, right? And for some reason that VoIP service failed to get activated on the ONU. But the other services it has are still working okay. But so the ONU itself may be in this degraded state, and maybe that tells ONOS or someone to go and audit something. And that may cause the flows to get sent again, maybe.
Yeah, I don't think we necessarily have to delete everything.
I think
yeah, the whole ONU hasn't failed, right?
In that example, the flows for subscriber unicast traffic would be their own flows, and those are still marked as success up and down the line. It would be maybe the one or two flows, or let's say just the one flow related to VoIP that decomposes into one OLT VoIP flow and one ONU VoIP flow. That may fail, and that may be pushed again. But the unicasts have failed, worked, and isn't altered. That's how I would expect it to behave.
I have a question here. So just trying to understand what kind of failures we're thinking about here. You're saying that first time the flow is pushed, it does not succeed, but later on when it is pushed, it succeeds. As in, what could be that kind of failures?
We're talking about failure, like we'll push a flow, and could be first time or eventually, but we'll push a flow, it fails. So what should we do with it? Like not deleting the flows. I'm okay with that.
So shouldn't we just report it back to ONOS, and ONOS marks the flow as failed, and let the northbound systems take care of it?
Yeah, I think this is what we're talking about.
So that's the whole transaction failure discussion, right?
Yeah.
So I mean, does the transaction succeed once it gets into the cores, the database, and the request then to push it down to the ONU, to the adapters, that succeeds in the, it was received and transmitted by Kafka successfully, but something in the processing caused that particular flow now to fail, right? Maybe it's run out of T-cons, maybe it's but something causes it to fail, and now the ONU itself, we really need some kind of state change to inform both the management system, the OSS guys, and ONOS perhaps now the system's in a state that's it's not fully operational anymore because a service I tried to create failed, right? So now what do we do, right? So now from ONOS's perspective, he could retry that particular flow, or could maybe withdraw it and add it again. From the management guy's perspective, they can come down and look at what's going on. They may do some other, management actions independently. But from the system operation perspective, it can potentially recover if it knows that the system is somehow degraded in a certain way, right?
No, so that's what I'm trying to imagine or figure out as to what kind of errors that could be. Are we saying that maybe we're running out of resources, so that at that point of time the flow provisioning failed, but when we do it at a later point of time, it succeeds? Or is it that there is something wrong in the flow itself? Maybe some parameter is wrong, and in which case, even if we try it multiple times, it's always going to fail.
That could be, and that would need some intervention from an operator, right?
Yeah. So
or a bug fix.
On the management plane, definitely there should be some alarms that should be raised, depending on the severity of the failure, right? And on the control plane, owner should have the picture that the flows it asked for installation have failed.
So what ONOS has is the flows aren't there. I asked for these flows. When I do a query, they're not there. So what ONOS knows is that the flows aren't there. It doesn't have any details about why the flows aren't there or where things broke. I just want to be clear on that. I agree that when something breaks, and we get the asynchronous message back up from the adapter that a flow was not pushed or was not successful. I do think we need to log whatever, make that surface the reasons for that as best we can. but Onos won't know about that. All Onos knows is I asked for X, I don't have X.
Yeah, so David, yeah, what I'm trying to say is instead of VOLTHA deleting the flow, in which case Onos would repush it, why wouldn't VOLTHA just tell Onos that this flow failed? I could not install this flow.
Well, I don't think VOLTHA does delete the logical flow or even the physical flows. I think Onos gets the request for the logical flow, decomposes it, sends out the messages to instantiate that on the device. Some of those may succeed, some of those may fail. When those fail, some of those fail, all Onos does, or sorry, all VOLTHA does is report up that that logical flow is not on the device, on the logical flow. It doesn't delete the flows that succeeded, for example. You know, the partial flows that succeeded. It just says my logical flow is not there and leaves the system in that state. And then when Onos goes and queries and says what flows are in the device, VOLTHA reports up that says this logical flow isn't there. And VOLTHA, or then Onos will repush. Additionally, VOLTHA was probably logging the message that said, hey, I took logical flow X, I decomposed it into logical flow 1, 2, 3. I pushed out 1, 2, 3. 1 succeeded, 2 succeeded, 3 failed. Therefore, logical flow A failed. That's what VOLTHA's reporting in its log or its events or whatever, however the mechanism happens. But to Onos, it's just saying the logical flow is not there. That makes sense? That was a little bit of a ramble.
Sort of, but how does it say that this flow does not exist? That means that flow should be present in the logical device table in VOLTHA.
It's not in the logical device table.
Yeah, because that is what it is reporting to Onos, right?
Yes. So the logical flow is not in the logical device table. Yes.
Yeah, so what I was questioning is, instead of it saying that the flow is not present, would it be okay to say that, yes, the flow installation failed, instead of saying that it is not present?
If in VOLTHA, we want to have a state for a logical flow that says failed, that's fine, but that doesn't go up to Onos. If a flow's in that state, a logical flow's in that state, when Onos asks us for those logical flows, we have to say it's not there. We don't have the option of telling Onos, yeah, we know about it, but it's failed. That makes sense?
Clearly showing if it's failed in VOLTHA would have some value. I think it would be, you could see what Onos says it failed and then go into VOLTHA and say logical and decomposed flows are failed, or what, subset of them failed.
I mean, I can see value in having that in Onos and having, sorry, getting confused, having that in VOLTHA, saying I got this logical flow, here's how it decomposed into physical flows, here's the ones that succeeded, here's the ones that failed. I can absolutely see that value, being able to query that out of VOLTHA. But with our interactions to Onos, it's just not there. Now the question is, how do we manage that via the VOLTHA API? Because right now the VOLTHA API has a get flows.
Get logical flows, really, right?
Right, yeah.
Okay.
Yeah, but
I mean, ultimately, it will be reported back up to Onos eventually through polling, through that function call.
Right, which means we need options to that function call. And we talked about needing these for some other reasons, saying, I need the logical flows, including failures. Maybe the default is I only get the ones that actually succeed. There's going to have to be some options around that, how you filter that back in that API.
The only reason I asked is because if we don't report it to Onos, as in if we say that the flow does not exist, Onos is going to repush it, right? Mm-hmm. And it would continue in that loop, right? If it fails every, Onos keeps on repushing.
That's exactly what happens today with an Ethernet switch.
Is it a behavior that we want?
It's a behavior that Onos does, right? There's no. That's how Onos.
But my question is really would Onos behave differently if we say that flow failed?
We can't tell Onos that flow failed. We can say, Onos, the flow's here or not.
Assume we have the mechanism to do so, and we implement that mechanism. would owners behave differently?
No. Well,
okay, what would happen?
You can't ask that question. You're saying assume this, assume this. Well, then I can assume it doesn't behave differently, right? So the question is, if someone's looking at Onos and they're watching what happens, they see flows go from continue to stay in a pending add state, then they can take an action today on that.
So right now, the scenario you just described is actually what we're doing today, where Onos sends a logical flow. Logical flow is decomposed down and maybe partially added. In Onos's point of view, a partially added logical flow is an added logical flow. And now it's the adapters that are in their own time looping forever, trying to repush. If we're going to have, or somebody's looping forever anyway, trying to repush, we might as well let Onos do it for everything in one place.
Yeah.
And maybe, I don't know, maybe you shouldn't loop forever, right? Maybe you should try a certain number of times and then now you failed. So, the state, so from an external management perspective, from the operations guy's perspective, they'd want to see something showing something's failed, right? Like, and presumably it could be an ONU, it could be an OLT, it could be an adapter, but so there have to be some state that's reported back to the operations guys, so that and potentially an alarm, right, saying that hey, something failed, with as much granularity as possible.
And that can come from VOLTHA.
Like the looping scenario, like let's, for one, whether it loops or not, I guess is really just behavior choice. But if it's all in one place, at least we know it's all in one place consistently behaving the same way. But let's say if it's intending add and it's looping forever trying to add a flow intending add, it's still reporting that it's intending add, right? It's not that the error isn't there. It's just the error is here, report up the error is here. Oh, by the way, I'm going to keep trying until told otherwise. And if you want to drill down into, Onos saying, I have a flow pending add, and then figure out, is it actually a, decomposed flow failing, then you go into Onos or go into VOLTHA, and then even an adapter level and say, okay, what's actually going on that's causing this trickle up failure of the logical flow?
Yeah, and normally you kind of aggregate up the chain in terms of, parent-child, so that someone's looking at the system from a high level can see that, hey, something's wrong. And now I need to dig down and find out exactly where that is, right?
And VOLTHA can send those alarms up to say, hey, look, a flow decomposition failed. Hey, I couldn't push. It can send those events up. It's just not going to come from Onos.
Yeah, Onos will just say this uni and this flow are failing to be added, but we're keeping adding it. If you want to know the specifics about the situation of that ONU and that uni, then it's more granular alarms and or querying VOLTHA to get the details.
Yeah, and potentially some substates off of the operational state, maybe degraded or resource limited or something.
Yeah, I mean the scenario I can think of is the splitter is going bad, and for whatever reason, previous flows were pushed to the ONU when the splitter wasn't damaged. Now the splitter is damaged, and we're trying to push new flows. For whatever reason, we can't get those flows pushed to the ONU, but we could to the OLT. Reporting from that level should say, yep, this one logical flow is failing. You've got to figure out that your splitter is failing, but that's digging into details.
Yeah, or rogue ONU, right? Somebody's transmitting when they shouldn't or something. So now I can't communicate with an ONU or multiple ONUs.
Of course, I'm picturing a bad action movie when a good ONU goes rogue. I don't know. Sorry.
Yeah, that's an ITU storyline.
So what we're trying to conclude is whenever there's a flow failure, it will be removed from the logical device in the core, and an alarm will be raised. Is that what we kind of
It seems to me we wouldn't remove it from the core. We would just mark it as failed in the core, and then when ONOS pulls it, ONOS will see it's marked as failed in the core, and then ONOS will decide to remove it and re-add it.
No, ONOS won't see it. Well, no, ONOS. Let me back up. I think what we said would we mark it in the core as failed. It's in the flow table, the logical flow table. But when ONOS queries, it's not in the logical flow table. So ONOS sees it as not added. Isn't that what we said?
So I guess it's distinction between showing something as there and failed versus just not showing anything.
Right, because ONOS, I don't think there's no way that I know of anyway, maybe I'm wrong, that we can reflect back to ONOS the failed state. All we can reflect back is what is our table. And ONOS then does a diff between that and what it thinks should be there and says, okay, this one's not there, therefore it's pending.
Well, I mean, a device state could somehow inform ONOS too if ONOS is looking at a particular device state, or if it's not looking at the state and just looking at events, then yeah, I mean, we'd have to go and poll and get the status, I guess.
Right, and so the difference would be we now have to be able to when we do get logical flows, we have to have an argument, if you will, to a parameter to that says, I want all logical flows with their status, or I want just the good logical flows, or installed logical flows. So ONOS can, when we give results back to ONOS, ONOS is only asking for the flows that are actually installed.
It's a difference in OF agent asking versus CLI asking.
Exactly. And again, you might, you might from the CLI want to be able to have that same filter capability, but yeah, there's a definite argument there somewhere. I suspect we need a generic filter mechanism on the API, and then the OF agent just uses that filter mechanism to get what it cares about versus the CLI does whatever it wants to do. And by default, it may just get everything, and then you can filter out based on your other command line options.
So, David, I was just looking up on this. So there exists OpenFlow error message, and we could set the type in that to flow modification failed, because the flow add comes in as a flow mod with add as the sub. So with flow mod failed and an OpenFlow error message, I think we should be able to say which specific flow mod request from ONOS failed. So I think we could figure out a way to report back to ONOS which specific flow failed.
And then ONOS may not repush, and is that a desired behavior?
Yeah, if that is the behavior we want.
Fair enough. I don't know what ONOS behavior will do. I know they're, but I suspect if it gets a failed, it's not going to repush.
Is it an ONOS behavior or one of the apps on top of ONOS behavior when you get a fail?
Apps create flow objectives. Flow objectives ONOS manages in its flow objective app, if you will, which is pushing down flows. That makes sense? So there's like a core part of ONOS that's just whole purpose in life is to push flows and monitor what flows are there. That's what it lives for.
Then we need to figure out when it cannot push a flow, or if you get a failure, what's the behavior?
I suspect if it gets a failure, and yes, I agree we need to look at it, but I suspect if it gets a failure, it may stop pushing that flow versus if the flow's not there, it'll continue to push it. And the question is, when we get a failure to push to an ONU, do we know if there's a distinction between we never want this one pushed again and we just want an error up, or hey, we push it again and we'll try again and maybe it'll work?
And maybe there's a limit on the number of tries.
But then someone has to start counting those tries.
Yeah, well, ONOS would have to. I but we also need to make sure the management system understands there's a failure as well. So someone needs to come and look at this if it persists, right?
Yeah, and I agree. I think VOLTHA will be spewing messages when something happens like that. The question is when something fails, when a flow push fails, do we want ONOS to retry, or do we want things just to stop and an error message and that's it? Typically, the behavior we've seen with ONOS today is ONOS will keep pushing, pushing, and pushing, and it's up to an external system to determine, hey, I pushed this flow down 5 minutes ago, it's still not there, I want to do something. Versus if this fail mechanism works, it may be, yeah, now there's a failure in ONOS on that flow, but who's going to do anything about that?
Well, how often does it retry currently?
I can't remember what the cycle is, and it's configurable, I think. It's pretty frequently, to be honest. But when you start scaling that up, that gets interesting too.
Right.
Okay, it's something that I guess we need to follow up maybe with Saral to figure out the behavior on ONOS.
Hey, I'm here. Do we want to today at least start with the hey? Who's here?
Yeah, I'm here. This is Saurav.
So what's the answer?
So I feel that reporting right error messages is good. Oh. Sorry, I dropped my phone. The reporting the right error messages up to ONOS is good, and the error message actually bubbles all the way up to the app, and so it's up to the app to withdraw a flow or a flow objective if they want to. If they don't withdraw it, then default ONOS behavior could be to retry. I think it tries every 10 seconds or something like that. But like David said, that's configurable. But the retry mechanism really helps when there are timing issues, right? So let's say a flow points to something, a group or something like that, right? And ONOS sends the group as well as the flow, and sometimes due to timing issues, maybe the flow showed up before the group did, and it could not be installed, but then later the group did get installed, and so the retry of the flow actually succeeds the second time. So that's one scenario where retries help. But in most other scenarios, lower down, if something went wrong in BAL and you can't recover from it, then retries are not useful. You just keep sending it again and again, and the same thing happens again and again. So you keep getting error messages. So it depends on how you write the app. You do get the error notification, and if you act on it, one of the things could be to withdraw the flow from the ONOS core.
Where do you get this error notification? Because it pushes down an OpenFlow protocol request.
Mm-hmm.
And you're saying if the OpenFlow protocol request returns an error as a response to that protocol request, synchronous response, then the flow gets marked as failed?
Yes.
Right, okay.
It's an error. So right. It's an error that you've gotten from the switch.
But it's not an asynchronous error. It's an error at the time of push.
No, it's an asynchronous error. It's an asynchronous error message that is created by the switch. It can refer to a flow or a transaction ID that had come with the flow when the flow was pushed down. But it's not like anyone's. OpenFlow isn't like a request response protocol, right?
So if it's marked as failed, ONOS will not repush it.
Sorry, I missed the last part. Can you repeat that?
Yeah. If it's marked as failed, a flow is marked as failed, ONOS will not repush it.
I believe so, but I have to check. The important thing is that I think the error bubbles up all the way to the apps. So if it bubbles up all the way to the apps can choose to pull the flow or not.
It bubbles up to the apps if the app's listening for an event.
Yeah. The apps have to be listening for error events to the flow objective. So when you create the flow objective, you can create callbacks for errors. Right? Okay. So when the app pushes a flow objective, it can at the same time say that, hey, if this thing errors out, then do this. So later when the asynchronous error message comes and it's reported, it's possible that the notification bubbles up to the app and then the app can take action. By default, I think even if things error out, my gut feel is that it still tries it. But today in VOLTHA, nothing errors out, right? I mean, ONOS pushed the flow showed up in the logical switch, all seems hunky-dory, but lower down there are problems. And
well, yeah, and the question is, if lower down we have a problem, do we want to push an error up or just not report that logical flow is installed so ONOS retries?
Yeah. You know, I've been debating this also since Amit brought it up yesterday. The thing is that if you don't, if the behavior is what it is today, then, you know, from an ONOS perspective, I see, okay, everything looks good. And then I dig down into VOLTHA to see, okay, logical device, yeah, that looks good. That's why ONOS says it looks good. Then I go into the physical devices and I see, oh, hey, these flows are missing. And then I go into the logs to see why they are missing.
And I think we're talking about a distinction between today's behavior and where we want to go anyway. Because where we want to go, or what we've been talking about to this point, was if a flow fails, it's not going to be reported up to ONOS as installed. So ONOS will stay in the pending add state. So there's a clear indication in ONOS, well, there's an indication in ONOS that the flows, everything's not good.
Yeah, I'm in favor of that, even though that might lead to ONOS retrying a few things. But that, like I said, maybe there's a way in the apps to prevent the retries. But at least an indication that bubbles up to say that, hey, there's something wrong here. I still think it's a good thing.
And now the question is, does that indication just say the flow, we just don't report that flow back, and so ONOS sees it as pending add? Or do we use this asynchronous message and say, hey, there's an error, so it becomes flow failed?
Yeah. I think an error message is the right thing to do.
And okay, with the possibility of it not being automatically retried.
Yeah. I think you should bubble up an error message. There are several error codes, and one of them can be used to signify. Bubbling it up to ONOS, at least, I think is the correct behavior of what VOLTHA should do. It won't prevent me from having to dig down into VOLTHA to see what went wrong over there, but the correct behavior certainly suggests that you should bubble it up. It shouldn't seem like everything is fine in ONOS.
So I agree with that. So when we have a problem in VOLTHA's flow table, logical flow table, we'll have the logical flow marked with a status error. When ONOS queries a flow table, we don't report those flows with error up because it's not installed. But when we do get an error, we also send a message back to the OF agent that says this flow has a problem.
Yeah,
has failed. I'm okay with that. I've never seen anything in ONOS actually handle a failed state, but that'll be good to see.
The other thing too to consider.
No, there are examples in Trellis, but anyway. That's.
Different adapters might have different behaviors with retrying. I know the ONU will keep retrying forever. The OLT adapter may not, and depending on which combination of adapters you're using, it would be nice if we always knew failed attempts would be retried or not be retried from one place.
I think adapters have to behave consistently or we're in trouble.
And just a time check, we are at the end of our allotted time, so we need to wrap up, and we'll drop the bridge soon. Any last comments?
I'm going to clean up the doc with what we have talked up to today, and maybe another times we need to review the rest of it. There's not much to review, but
can you put this doc in the design docs folder?
Yeah, I will.
Thank you.
Okay, thank you, Ken.
Also, do we need a device state model change to reflect something like this? Or that we can discuss that later, I guess.
I don't think it's device state. I think it would be just the flow state on the device.
Right, but that if the device was an ONU and it can't provide a service, for instance, now it's degraded, right? It's not fully operational.
I think querying the device's flows, or looking at the device's logical flows to say, all right, the device is there and running, but two HISA flows are working, but the one VoIP flow isn't working. You get your conclusion drawn from that.
Okay.
But it's something we can also add in a follow-up discussion to see if it's something that we need to tackle.
Okay. Any final comments? All right. Thanks everyone for the discussion. We'll go ahead and stop the recording and close today's meeting.